Hello, I'm Michael from OnlineMathAcademy.com, and in this video we're going to discuss radians. What's the deal with radians, many students ask. Radians are a way to measure angles in addition to degrees. So many students are used to measuring angles in degrees, but when they get introduced to this concept of radians, they ask themselves the question, where did this come from? What's going on here? Well, in this video, we're going to try to get to the bottom of radians, and I hope by the end of it you understand where the radian measure comes from and how we use it. It's imperative to understand radians and measuring angles in radians if you are going to go on to calculus, because it's almost always used and degrees are almost never used. Okay, so to begin to understand the concept of radians, I first want you to consider a circle with a radius of length r. So there I've drawn a circle and a radius, and that radius is of length r. Suppose we want to construct an angle with one of the sides being the radius that I've drawn, and we want to construct that angle such that the arc of the circle that subtends the angle is of length r. There's a visual picture of what I mean. So there we have an angle, I've called it theta, which is a common name for angles. And as you can see, the arc of the circle that subtends that angle, I've drawn in blue, and that arc has length r. Now, when I say that arc has length r, I mean that if we were to take that curved arc and straighten it out, it would have length r, just like the radius. We say this angle theta has an angle measure of 1 radian. I wrote 1 radians, but it's really plural, singular, 1 radian. So let's continue with this idea, and what I want you to do is, I want you to take the whole circumference of the circle and stretch it out into a line and lay it horizontally like I did there below. How many radiuses would be contained in that entire line? Well, we know that the circumference of any circle is equal to 2 pi r, or 2 times pi times the radius of the circle. Therefore, that length is 2 pi times the radius. I wrote radians here in pink, and I was wrong. It should be radius, so I apologize for that. But yes, we know that the length of that arc, if we were to lay it and horizontally or vertically or whatever, but basically just make it into a straight line, straighten it out, it would have length 2 pi times the radius. Therefore, an angle theta that has an entire circle as the arc that subtends it has an angle measure of 2 pi radians. So, 2 pi radians. Suppose we want to construct an angle theta that half the circle subtends that angle theta. Well, if in the last circle we had 2 pi radians being the angle measure of an angle that has the whole circle's arc subtending it, then if we're only looking for an angle that's half that measure, of course, that angle would be pi radians. So here theta is pi radians because it's half of 2 pi radians. Half of that is pi over 2 radians. Half of that is pi over 4 radians. I think that you're getting the pattern here. But it all goes back to the fact that if you had an angle that the arc of the circle, the arc of the entire circle subtended that angle, it would be equal to 2 pi radians. So what might an angle with a measure of 5 pi radians look like? Well, going back to the previous slide, we know that an angle that half the circle subtended was pi radians. So if we're looking for 5 pi radians, we're looking for an angle that we're going around 5 semicircles, because 1 semicircle is pi radians, so 5 semicircle is 5 pi radians. And that's what we get. So we go around 1 time, 2 times, 3 times, 4 times, 5 times. Now that angle looks the same as our pi radians angle. And for visual purposes, it is. For visual purposes and most practical purposes in mathematics, pi radians is the same angle as 5 pi radians. Just like an angle of 360 degrees is the same as an angle of 720 degrees, or an angle of 180 degrees is the same as an angle of 540 degrees. So what might an angle theta with an angle measure of negative pi over 2 radians look like? Well, as you saw in our previous one, we started from this positive x-axis almost, or, over here, and we went up. And that's the positive direction. The positive direction's up, so I started going up. Well, when we're dealing with negative angles, we start here, and we go down. And we saw that pi over 2 radians looked like a 90-degree angle. And guess what? Negative pi over 2 radians looks like the opposite 90-degree angle when we go down from that horizontal line. What might an angle theta with an angle measure of negative 7 pi over 4 radians look like? Well, it would look like that. We know that negative 8 pi over 4 would be the same as negative 2 pi radians, right? And that would go all the way around in that direction. So here we go almost all the way around, and we leave pi over 4 radians left to still be going, but we don't want to do that because we're only going negative 7 pi over 4 radians. I hope this cleared up some of your confusion about where radians come from. And to get more math help, please visit onlinemathacademy.com, where I offer private online math tutoring and test prep. It's the most effective way to get better at math, whether you're really struggling or you're a person that wants to go to the highest possible level and get that A in the hard AP class. Either way, the best way to do it is with private, focused, customized tutoring, and with the online format that I use in my virtual classroom, you can be anywhere in the world with a broadband internet connection and get that tutoring. Anyway, I hope you enjoyed this video and it cleared up a lot for you. Have a great day.